The NOR gate acts like an OR gate with a NOT on its output. We see from its symbol that it looks like an OR gate, and it borrows the little circle on the output side from the NOT gate. This is the NOR gate. It has two inputs. We'll call one A and the other B. And we'll call what it outputs not A or B. Let's look at the rule for the NOR gate. NOR is opposite of OR. It outputs a 1 if both the inputs are 0. Okay, let's fill in our logic gate with all the possible solutions, all the possible combinations that could be input to the NOR gate, to this 2-input NOR gate. We could get a 0 and a 0, 0 and a 1, and a 1, 0, 1, 1. We're going to call our output not A or B. And let's evaluate this. Starting with the first column, I'm going to think about each one of these, and I'm going to think about how the OR gate would have reacted and do the opposite. So for a 0 and a 0, an OR gate would have said, would have output a 0. But in this case, we're going to put the opposite for the NOR. We're going to put a 1. All right, next row, we've got a 0 and a 1. The OR gate would have output a 1. In this case, the NOR gate's going to do the opposite. We got a 0. The next row, we got a 1 and a 0. The OR gate would have output a 1. NOR gate does the opposite. Last row, we've got a 1 and a 1. The OR gate would not have cared that there were two 1s. It would have output a 1. But the NOR gate does the opposite. Outputs a 0.